Welcome back, Honors Algebra 2 students. Lesson 7.4 here. So actually this is one of my favorites. I know that it may not be yours, but hopefully you find a little bit of joy in doing some algebra here, especially hopefully after this lesson you'll find it somewhat easy. And so what this one is actually talking about is we're going to talk about adding, subtracting lovely fractions with unlike denominators and with like denominators. So we'll start easy and kind of build our way up. And they get into simplifying complex fractions. So there's a lot of stuff going on in this section. And so we're gonna, I'm gonna kind of work my way through. I encourage you to pause the video if at any time you need to kind of, rewatch any part of it, just because this is kind of a heavy section. All right, let's get started. So complex fractions. So I talked a little bit about that, right? So I said we're going to talk about a complex fraction. Well, what a complex fraction is, it's a fraction that contains a fraction in the numerator or the denominator. So to be honest with you, I don't really care if you know the definition. But if you look at something like this, so there's 6 over x minus 2. This is a rational expression. Well, imagine if I kind of did one of these things with it. It looks a little more complex, right? So this is a fraction in the numerator and then a fraction in the denominator. And then just for fun, I added in an addition problem as well. So we're going to basically, a complex fraction is kind of in the name, it's more complex, right? So it's going to add in those addition, subtraction skills that we're going to talk about, maybe even some multiplication, division, obviously with the fraction. So I'm going to show you how to I'm going to show you I'm going to show you the way I do this, and it may be a little bit different than if you do any kind of look online, and I know that there's tons of YouTube video stuff that other people are doing. So there are many different ways, or a few different ways to do these types of problems. So, if this method doesn't work, or if you feel like you want to see something else, by all means, go ahead and kind of see what else is out there. All right, so it's easier for me to kind of explain some of this stuff as we kind of do some examples. All right, so let's start with kind of our adding, subtracting. So in order for us to do complex fractions, right, we have to know how to do kind of the stuff that's within it. So first and foremost, we needed to be able to add fractions with like denominators. So we did this in that warm-up, remember? So I talked to you about how those same processes, those same skills that you learned back in the glory days of elementary school, 4th and 5th grade, are going to be the same processes we do here. So for example, if you notice, we both have a denominator, both these fractions have a denominator of 21x. So when we add fractions, we keep the common denominator and we add the numerators. So 5 plus 2 is 7. The other thing I want you to remember is that always, and just this is always the same back in like elementary school too, reduce your final answer. So for example, 7 over 21x, 7 and 21 are actually common factors, right? So I can reduce that to 1 over 3x. So common denominators are actually pretty easy, right? We're not really doing much with it. We're just keeping the denominator and adding the numerator. If you want to see it, I'll show you one more example. So this one just kind of has a little bit more rational expression to it, right? So we have a binomial. So this is subtraction, obviously, but notice that my denominators are the same. So we're going to keep the same denominator, and this time we're going to subtract the numerators. So it's 4x minus 3. That's how it would look. At this stage, this is where now we're going to kind of revert back to what we did in the previous video. So we're going to factor out what they have in common and see if we can reduce. So in the numerator and denominator, since there's really nothing I can factor out, then this is the simplest form of your answer. And so that's how you know you're finished, is when nothing cancels, right? So we factored, in this case it doesn't factor, and then nothing obviously cancels since we didn't factor anything out. All right, so that was the easy stuff. Now let's talk about unlike denominators. Okay, so I'm going to walk you through an example. And hopefully this makes sense. All right, so we have 8 over 12x squared and plus x over x squared plus x. All right, first rule of thumb is you will find, and I'm just gonna write some rules here on the side for those of you who like to follow steps. I'm one of those people. Your first rule is to factor everything. And that's going to be kind of your first rule for all of these problems. All right, so factor everything. So what I mean by that is all the numerators, all the denominators. In this case, there's not a whole lot to factor, but this denominator here can factor, I can factor out an x. So I'm up with that. All right, step number 2. Once you've factored everything, you want to find, and just like if this were like normal adding or subtracting fractions, you want to find a lowest common multiple as your common denominator. So, okay, so, like if I was to add, 1/5 plus 2/7, the lowest common denominator here would be what, 35, right? And so one of the ways to always get a common denominator is just to multiply the denominators together. Not always will that give you the lowest common denominator, but it will give you a common denominator. So it's always better to find the lowest common denominator. But if you are stuck, remember that a common denominator will always be when you multiply these two things together. So if you don't have any other options, right? So if you can't figure out what the lowest common denominator is, at the very least find a common denominator by multiplying your two denominators together. All right, so here's how you do this with polynomials. You have to look at the numbers, okay? So 12, there's no number over here, so obviously it's 1. So a common denominator, or a lowest common multiple of 12 and 1, so we're just looking at the numbers, would be 12. Okay, we have x squared and x. The lowest common multiple, so that's kind of my next step, right? So these are all factors. So x squared is a factor, because it's like, we didn't really factor it out, but it's kind of hanging out here. And then x. The lowest common multiple between x squared and x would be x squared. The way I kind of look at this is if you have like a common factor, you have to take, like if there's 2 here and 1 here, the lowest number or the lowest value that they can go into is the highest power. Okay, so like out of x squared and x, you have to have an x squared over here as your common multiple. Because x has to go into this, but so does x squared. Like if you just wrote x here, I don't have any way for me to multiply x squared by something to get to x. Because x squared doesn't, unless we're going to use negative exponents, which we're not, x squared times something doesn't give me x. So I have to have, at the very least, whatever the highest power is, has to be in my common denominator. And then look at your other factors. Well, I have an x plus 1, but then I don't have an x plus 1. You have to have at least one of every factor in your common denominator. So that is your lowest common multiple. So notice, I looked at my numbers separately, so that was 12. Looked at my x squared and my x, and got x squared, so it's the highest power. And then I looked at x plus 1, and there was no x plus 1, but I need to have at least one of every kind of factor. So that's your common multiple, your lowest common multiple. So I'm just going to go ahead and scale up my fractions. So what I mean by that is you're taking this denominator to this denominator. So what do you multiply 12x squared by to get to 12x squared x plus 1? Well, I multiplied by, the only thing I'm missing to get from here to here is x plus 1. So if I multiplied the denominator by x plus 1, guess what? You're going to multiply the numerator by x plus 1 because we're scaling up this fraction. So the new numerator is 8 times x plus 1. Same thing here. To get from this denominator to this denominator, what did I multiply by? Well, it looks like I need 12, and I need another x, and that's it. So 12x is what I multiply by. So if I multiplied the denominator by 12x to get to here, I have to multiply the numerator by 12x. And so this now gives me 12x squared. So once you find your lowest common denominator, lowest common multiple for your common denominator, all you're going to do is scale up your fractions. So again, you're just kind of looking at what did you multiply one denominator by to get to the next one, and then do that same thing to the numerator so you can scale up that numerator, and then go ahead and follow suit with the next one. Now that you have the same common denominator, now we can kind of revert back to what we did up here. You keep your common denominator and add the numerators. So 8 times x plus 1 plus 12x squared. Okay, so unfortunately we're not finished. There's a little bit more work to do. So I'm actually gonna write the steps on a separate sheet of paper because I ran out of room. So for those of you who like the steps, remember our first step was to factor everything. Step 2 was to find the lowest common multiple as your common denominator. Step 3 was to scale up each fraction. So that's how I was just kind of showing you how I did that. Step 4 was to either add or subtract. So obviously here we added. So we keep the same denominator and then add or subtract the numerators. And then step 5 is to factor and reduce. So I want you to kind of remember those rules. So this is kind of my game plan that I use for any time I'm adding or subtracting fractions. So anytime I have a rational equation or rational expression that I'm adding or subtracting, I kind of follow these steps. All right, so what that means is on this problem, in order for me to factor and reduce, I need to expand this all out. So I'm going to kind of write it down here. So I'm going to distribute this 8. So I get 8x plus 8 plus 12x squared over. I'll keep the denominator the same. And you'll see why in a second. So basically what I'm trying to do is simplify this numerator. So I want to combine everything here because I want to see if it can be like reduced. I want to see if we can factor and reduce. So on this one, if you notice, I can actually, this is a trinomial. I'm going to go ahead and rewrite it. I'm going to factor out, I'm going to rewrite it first because I like to have it in standard form. It's just bothering me. Okay, so now that I have it in standard form, what I'm going to do next is factor out. It looks like I'm going to factor out from the numerator. It looks like I factor out a 4, right? So if I factor out a 4, I'm left with 3x squared plus 2x plus 2 over 12x squared x plus 1. Since the denominator had already been factored, we didn't really need to do anything fancy with that one, right? So we didn't have to expand it out and then refactor. That would just be silly. So we just kept that one kind of as is. The only reason why we had to do that with the numerator is because of this plus sign here. We had to combine these two terms and refactor it, okay? It looks like this 4 and the 12 can cancel. Those are common factors. Let's see here. Can I factor 3x squared plus 2? I don't think so. So this would give me 3x and x. 2 and 1 are the only factors here, so that would be 3 and 2. No, and that would be 6 and 2. Nope. So that one's not factorable. So I was just trying to factor this triangle here and it doesn't work. So that means my final answer at the end here, since I reduced the 4 and the 12, my final answer is 3x squared plus 2x plus 2 all over 3x squared x plus 1. So notice that the numerator is as factors as it's going to get. So we're not solving anything here, so we're not using quadratic formula or anything fancy. And then the denominator we left in factored form because that's how I want you to leave your final answers. Okay. So that's adding and subtracting. To be honest with you, you're going to need to practice that one. Adding and subtracting is probably one of the more challenging just because there's a lot of steps. Notice that I obviously went through quite a few. I would encourage you to practice, practice, practice. We'll do some more in class, but you're going to need to try this on your own so you can figure out what it is that you are a little bit unsure of. All right, so like I said, this is kind of a big lesson. So let's go ahead and move on. I'm going to go ahead and go over an example of subtraction just because I think it would be beneficial for us. So let's do another example. So 5x minus 1 over x squared minus 3x plus 2 minus negative 2x minus 1 over 2x minus 4. All right, so remember our rules. So we're going to factor everything. We're going to find a lowest common multiple as my common denominator. We're going to scale up each fraction. We're either going to add or subtract, and then we're going to factor and reduce the numerator. I'm going to add that in there, the numerator. The only reason I add that is because the denominator should already be reduced. All right, so let's see what we have here. Let's factor everything. This numerator, okay, so it looks like this denominator can factor into x minus 2, x minus 1. This denominator I can factor out a 2. And I think that's it. All right, let's find a lowest common multiple as my common denominator. So let's start with 2. Well, I need to have a 2 in there. as my common denominator, right? Because I have to have at least, in terms of numbers between 2 and 1, right? There's a 1 out in front. The lowest common multiple between 2 and 1 is 2. They both have an x minus 2, so we can include that as my common denominator. And then this one has an x minus 1, but this one doesn't. So remember, we need to have at least one of every factor in my common denominator. In order for all of these things to kind of go into where, I got to have at least one of every kind of factor in my common denominator. All right, so I don't need to have two x minus 2's because they each only have 1 in common. And then I had to have at least one x minus 1. All right, so that one looks good. Let's go ahead and scale it up. So to get from here to here, the only thing I'm missing is the 2. So I multiplied by 2. Let's multiply the numerator by 2. So I get 2 times 5x minus 1. To get from here to here, the only thing I'm missing really is the x minus 1. So I'm going to multiply negative 2x minus 1 times x minus 1. Okay. Remember, we're going to combine these two. So we have keep my common denominator. And now we're going to subtract the numerators. So I have 2 5x minus 1 minus negative 2x minus 1 and then x minus 1. So this is my problem now that I'm dealing with. I've got my common denominator. We're good to go. The only thing left now is to simplify that numerator. So now I'm going to go ahead and expand all this stuff out. Be careful with your negative sign here. You're going to eventually have to distribute. So watch all your signs. So I'm going to simplify my numerator. So on the top, I'm going to get 10x minus 2 minus, and then I'm just going to go ahead and distribute this. So I get negative 2x squared. Let's see here, multiplied. Negative 2x times negative 1 is positive 2x. And then negative 1 times negative 1 times x is negative x. And negative 1 times negative 1 is positive 1. So I'm just taking this kind of nice and slow, showing all my work so that you guys can follow. So I just distributed these two binomials here. I'm going to go ahead and distribute through with this negative here. So I have 10x minus 2 a negative times a negative actually is a positive. So positive 2x squared minus 2x plus x minus 1. Lots of simplifying here. So I just go ahead and distributed this negative. Let's combine some like terms on the top. So I'm going to put this in the right order. Okay, so I want to put my x squareds first. So 2x squared. Looks like there's only one of them. Let's combine all my x's. So I have 10x plus x is 11 minus 2 is 9. And then negative 2 and negative 1 is negative 3. Okay. All right, so I've simplified my numerator as much as I possibly can. The last step is to see if you can factor and reduce. So the denominator is already factored. What you're going to try here is to factor this numerator. And so this is where all those factoring techniques come into play. So whether you use AC method or whether you use guess and check. So I'm going to go ahead and put the 2 in x and the x in here. Factors of 3, which is kind of nice, is only 1 and 3. So if I put 3 here and 1 here, can I get 9? I get 6 and 1, that's not going to work. If I put 1 here and 3 here, I get 2 and 3, and that's not going to work. All right, so I slowly, I went ahead and tried to do the factoring. It doesn't work. So if nothing factors, then this is your final answer. So I cannot factor that numerator, so that's it. This is all I have left. Okay. The bottom here, extra practice, is just kind of what we just went over. So you'll notice that there's some common denominators here that are already alike. So those ones are kind of easy. So the ones on this page, I'll go through answers at the end. And then if you switch to page 209, what it asks you to do up here is just kind of getting a little practice with finding a common denominator. So if you had all of these as denominators, what would your common denominator be? Your common denominator would be. So what they're asking you is you had 9x cubed, and then if I factored this one, I would factor out a 3x, and I'd be left with x minus 7. So what you're looking at here is what is my common denominator between all of this? And so if you're looking at this, your common denominator 9 and 3, the lowest common multiple would be 9. X cubed and x, remember you're taking the highest power. And then you have to have at least one of every factor, so we have x minus 7. So this is just kind of an activity and just trying to get us in the habit of looking for a common denominator. Let's try number 6. So if I had x plus 5, and then let's factor that one. I think it does factor. So this is 2x and x. Yeah, it does. So plus 1 and plus 5. So if I had those two as my two denominators, my lowest common denominator, so they both have an x plus 5 in common, so I can have one of those. And then I have to have at least one 2x plus 1. So this would be my common denominator between those two, if those were my denominators. So I'll have you practice number 7, and again, I'll go over answers at the very end. 8, 9, 10, and 11, those are all addition and subtraction. So again, just kind of making sure that you're finding common denominators, you're scaling things up. And then I'm going to go over how to do complex fractions in a minute, but I'm going to do one of these examples with you. So I thought maybe I would do, let's do number 10 together. And that way you can try 8, 9, and 11 on your own, okay? All right, so I'm going to follow the rules again. This is just an addition problem. Let's factor everything. I'm going to give you a little hint. A lot of times, if you're finding a common denominator, look at what your other denominator is. A lot of times that's one of your factors. Like if you're trying to factor this one, a lot of times it has to be one of those just because it's gonna, they wanna, it's just kind of a nice rule of thumb here. Just kind of look at that. That kind of gives you a little hint of what you're gonna be looking for. All right, so if I had 2x plus 1 and then 2x plus 1 and x minus 3, my common denominator would be 2x plus 1 because I have one of those in each of them. And then I need x minus 3. All right, let's scale up our fraction. To get from here to here, I need to multiply by x minus 3. So I get 3x times x minus 3. To get from here to here, I don't really need to do anything. So all you're really doing is multiplying by 1. So that just gives me 10 on top. It's already, that was your lowest common denominator. All right, so remember what we're doing. We're going to keep the common denominator. So 2x plus 1 and x minus 3, and let's add our numerators. So 3x, x minus 3 plus 10. Next, go ahead and reduce everything possible. So let's go ahead and reduce that numerator. So I'm just going to distribute out the numerator. So I get 3x squared minus 9x plus 10. And then keep my denominator the same. And then let's see if this can factor. Might not, I don't think. Let's try it. So if I had 3x and x, factors of 10 are 5 and 2, or 10 and 1. So 5 and 2, if I did that, I would have 6x and 5x. Well, 6x and 5x cannot add or subtract to 9, so I can't do that. So if I had the 2 here and the 5 here, this would be 15 and 2, and that's not going to work. And then 10 and 1 is not going to work either. So what this tells me is that this is my final answer. That can't be factored. Now, I know we've done a lot of examples where it doesn't factor at the end, but again, there's going to be equally number of examples where it does factor, so you do want to check. So I will leave 8, 9, and 11 for you to practice. Again, this is going to be something that you definitely want to practice. And then I'll give you answers here at the end of the video. All right, let's do some complex fractions. There is not enough room on this paper for complex fractions, so I encourage you to go grab some paper because it just gets a little sloppy. So I'm going to write down the rules for complex fractions in case you care. All right, so number 1, just like the other one, factor everything. So I'm going to show you the rules first and then we'll kind of follow them. Number 2, we're going to multiply the numerator and the denominator by our common denominator. Okay, that sounds kind of weird, and I'll show you how to do that. Number 3, we're going to factor everything. So, and then number 4, we're going to simplify. So obviously step number 2 is the big one, right? We got to multiply the numerator and denominator by a common denominator. It sounds a little crazy. Let me show you how to do it. All right, so I'm going to go ahead and write this on a separate sheet. Well, I can do this one actually on this paper. Okay, so this one's fairly straightforward because there's not a whole lot of stuff going on. But when I do number 13, I'll do it on a separate sheet of paper. So the first thing I want you to do is look at all of your denominators. So including all of the numbers. So in this case, I have 10, I have 1, I have 1, and I have 10. So I factored everything. Well, it was easy. There's nothing needed to be factored in this one. So step number 2, so we factored everything, step number 1. Step number 2, multiply the numerator and denominator by a common denominator. Okay, so you need to find one common denominator between 10, 1, 1, and x. So what does 10, 1, 1, and x? What's my lowest common denominator, or least common multiple? Well, 10 is my only number, so I need to have 10. And then x is my only variable, so I need to have x. So what I'm going to do here is I'm going to scale up. Now, I do this a little bit differently. There's a couple ways to do this. What I do is I erase all of my fractions. So I scale up all my fractions by this common denominator. So I take 10 over x and multiply it by 10x. I take negative 3 and multiply it by 10x. I take 5 and multiply by 10x, and I take 1 over x and multiply by 10x. So I scale up this whole thing. And the reason I do that is so that all the fractions go away, except for this one, the big one in the middle. But it just makes my life a lot easier. And so, like I said, there are other ways to do this, but this is the way I do it. All right, so what I mean by that, x over 10 times 10x. So if you think of it on the side, this is, whoops, that's not what I wrote. You're taking x over 10 and you're multiplying by 10x over 1. The reason we do this, the reason I scale this up is so that my denominator goes away. So in other words, I'm canceling out my 10s. What am I left with? Well, if I cancel out my 10s, I'm left with x times x, which is x squared. So if I multiplied x over 10 by 10x, I'm left with x squared. Minus 3 over 1 times 10x. Well, 3 times 10x is 30x. That one's kind of an easy one. Same thing with 5, right? We get 50x. 1 over x times 10x. Well, if I multiply, think of this as like, 1 over x times 10x over 1. The x's would cancel, and I'm left with 10. For me, this is a much easier problem to simplify than trying to deal with this. So now that I've kind of gotten rid of all of my, fractions within the fractions, now all you're doing is factor everything. So go back to here, factor, simplify. So if I factor my numerator, I'm going to factor out an x. And then I'm going to factor out a 10 on the denominator. So I factored everything. See if I can cancel. Notice that nothing cancels here. So the x and the 10 obviously don't cancel. These are not common factors. So this is your final answer. Even though this and this they're the same thing, I would prefer you write your answer in factored form, because what that does is it shows me that you tried to see if something cancels, and that's kind of ultimately what I'm looking for. That's how you deal with complex fractions. The other way of doing this, and this is your preference, is you could kind of treat these as two separate problems. You could find a common denominator for the numerator and then subtract, and find a common denominator for the denominator and then subtract, and then put those two fractions together and divide. I don't like doing it that way. I find it to be more work. So like I said, what I do is I scale everything up, get rid of all the fractions, and then just reduce. Let me show you how to do that one on a more challenging example. So let's look at number 13. Notice I'm grabbing extra paper because, they don't give you a whole lot of room on this packet. All right, so here is our fractions. Okay, let's start with our rules. Number 1, factor everything. So let's do that. All right, so this numerator can factor into, I get 12 over, what does that factor into? 4 and 7 factors into x. Actually, to be honest with you, a lot of times, notice that this is what the same, look down here. They're gonna give you some clues. All right, so the only thing that could factor was this one. So I factored it into x minus 11 and x plus 4. So now what I'm going to do is I'm going to multiply this whole thing by a common denominator. So the common denominator between this and those three, okay, I have an x minus 11, because I need to have that, even though it's not in this term, I need to have one of everything. I have an x plus 4. And then, do I have anything else? No. So my common denominator is x minus 11, x plus 4. So what I'm going to do is now I'm going to multiply this fraction by this fraction by this, and this fraction by that. And this is what it would look like. So if I multiplied 12 over x minus 11 times x plus 4 by x minus 11 times x plus 4, all of this would cancel, and all I'm left with is 12. Right? This would all cancel because this is on the bottom, this is on the top. If I did this one, the x minus 11s would cancel, and I'm left with 2 times x plus 4. Plus, and then here, the x plus 4s would cancel, and I'm left with x minus 11. Fantastic. Much easier problem to deal with. Now that we got rid of all those fractions, let's just simplify what we can simplify. So in order for me to factor this denominator, I'm going to have to expand this out. So 2x plus 8 plus x minus 11. Let's combine some like terms. So that's 3x minus 8, 9, 10, 11, 3. All right. Now that I've got it combined, let's factor and reduce. So I can factor that denominator. I can factor out a 3. And then now I can reduce common factors. So the 3 and the 12 reduce to 4 over x minus 1. And that's how you deal with that. So is this the easiest thing in the whole wide world? No. But practice makes perfect on this. I'm going to be very, very honest with you. So you need to practice this. You definitely need to practice this. So I'm going to give you guys some time to work. For those of you who want to know answers back to all of the problems that we did in here, as you're kind of practicing this, you can pause the video if you don't want to see all the answers. But let's go back. I'm going to go back through and just give you all the answers to all these problems. All right, so I'm starting on page 208. The answers are, for this one was -4 over x minus 1. For number 2, you should have gotten 5x over 3x minus 5. For number 3, I got 6. For number 4, I got 2x. Okay, on to page 209. Okay, for number 7 at the top, so for the common denominator between this and this, I got x plus 3, x plus 2, and x minus 6 would have been my common denominator. For number 8, my final answer was 37 over 10x. For number 9, my final answer was 6 and then 3x plus 19 over x minus 2, x plus 8. For number 11, my final answer was x minus 2 over x plus 1. And then for those of you who are interested, I'll give you one more problem for the complex, since they didn't really give you a whole lot of problems for complex. If you want to grab a sheet of paper, I will give you another problem to try if you're interested. So let's do 6 over x minus 2 over 1 over x minus 2 plus 3 over x. So again, you can pause the video now if you want to try this on your own, and then I'm just gonna give the answer here in a sec. So if you want to try this on your own, just pause the video and then turn me back on when you want to check the answer. All right, so I got the answer for this one to be 3x over 2x minus 3. All right, so hopefully you found some success. What I would do is bring any questions to class. I know this was a long video, so thank you for bearing with me. And all right, I'll talk to you later. Bye.